It starts not with a bang, but with an alert. A silent flag in an automated system at an observatory in the Atacama Desert. A faint smudge of light, moving fast where no light should be. It's an asteroid, and it's appeared out of our greatest blind spot, the blinding glare of the sun. Within hours, the discovery is confirmed by other stations, and the data flows to the International Asteroid Warning Network. They won the numbers. It's big, 700 meters across, a skyscraper of stone and metal tumbling through space. Its orbit crosses ours. Initially, the threat is categorized on the Torino scale as a 1, a routine discovery meriting careful monitoring. But as observatories around the world track its faint path at dawn and dusk, the orbital calculations are refined. Within a week, the rating climbs to a 4, then a 7, a high level of threat, unprecedented in modern history. The world now knows. The news is a constant low-level hum of anxiety across the planet. Every night, the headlines update with the latest probability figures. We've seen scares before. Just last winter, asteroid 2024 YR4 had its impact odds fluctuate wildly before dropping to nearly zero. But this time is different. The uncertainty window is shrinking, and the blue marble of Earth remains firmly inside it. They map the potential impact corridor, a devastating path stretching across entire continents. The question is no longer about probability. It's about a deadline. We have 18 months. The options are stark. There's the brute force approach, a nuclear device. Detonated at a standoff distance, it could vaporize the asteroid's surface, pushing it off course. But it's a wild card. The blast could fracture the object, turning one giant problem into a shotgun blast of smaller, equally deadly ones. Not to mention the geopolitical nightmare of launching a nuclear weapon into space. There are more elegant ideas, like laser ablation, but they require years of sustained focus on the target, time we don't have. Then there's the kinetic impactor, a cosmic cannonball, a heavy, fast-moving spacecraft designed for one purpose: to collide with the asteroid and nudge it into a safer orbit. It's a strategy we've actually tested. 3 years ago, NASA's DART mission successfully slammed into the asteroid Dimorphos. It was our first attempt to move a celestial body, and it worked. The decision becomes clear. We have to hit it. A rocket built for this exact contingency is moved to the launch pad.
The world watches, united not by choice, but by necessity. The launch is flawless. For months, the impactor sails silently, a tiny needle crossing an immense void. Onboard computers make the final course corrections. The last image sent back is a field of gray, cratered rock rushing forward to fill the screen. Then, static. An agonizing wait begins. For days, the most powerful telescopes on Earth and in orbit stare at that point in space, measuring the faintest shifts in light. The confirmation finally arrives, not as a shout, but as quiet, verified data. The trajectory has changed. A tiny nudge, millimeters per second, but compounded over millions of miles, it's enough. The asteroid will miss. A collective, global sigh of relief. But it's a sobering victory. This was a failure of detection, not of response. We were blind to a threat from the sun. It makes NASA's NEO Surveyor, the infrared space telescope launching in 2027, not just another mission, but an essential piece of planetary security. It is designed to be our eyes in the glare. We survived this one, but the sky is full of rocks. Our watch has just begun.